Hey guys, today's lesson is on general angles and radian measures. So we are going to be converting angle measures between radians and degrees, and then we're going to draw and calculate angles. Okay, so a radian is another way to measure angles. Typically we measure angles in degrees, and if we're looking at a circle, which is what I want you to be thinking about this out of, a total circle, if we start at this point right here, remember that the entire way around the circle all the way back to our starting point is 360 degrees. Okay, so that's going to be an important little note here. A radian is a measure of the radius. So imagine we took the radius of this circle and we put it on the circumference, which is the outside of this circle. If you were to lay it out, that's what it would look like, is that R distance right there that's kind of curved. So a radian, like I said, it's a measure of an angle using the radius as its reference. This is kind of a weird concept, but what this generates back to is when you think about circumference, the formula for that is 2 pi r. 2 pi r gets us the whole way around the circle. R represents the radius, and then pi is our special constant that we use. So 2 pi r gives us the circumference. So this equals 360 degrees. But what we want to find is just what a single unit or a single radius would equal. So if we were to, or not a single radius, excuse me, what would happen if we took away the 2? If we were to divide both sides by 2, you would get pi times r equals 180. So pi times the radius, that gives us this conversion that we have down here. Notice these two right here. So to rewrite degree measures in radians, we multiply by pi over 180. And then to rewrite radian measures, we multiply by 180 over pi. The reason is because pi, a single pi is halfway across the circle, whereas 2 pi is the whole way across the circle in radians. And we know the whole way across, or the whole way around a circle is 360, halfway is 180. So that's why pi and 180 go together. So I'll show you how this works. It's kind of a weird concept to teach online. I apologize. It'll get better with time though. So 320, that's in degrees. We want to convert that to radians. So if we want to convert that into radians, we got to use this top measurement right here, or this top conversion. So we're going to multiply these fractions together. Remember that when you multiply fractions, you multiply across. So 320 times pi, and then 1 times 180. And then we just want to simplify. So 320, we know we can take out a 10 from both that and the 180, giving us 18 and 32. And then we can cut both of those in half, giving us 16 and 9. So the final answer is going to be 16 pi over 9 radians. All right, so 320 degrees is 16 pi over 9 radians. Kind of weird, I know. But we have to do this when we are working with some of the trig concepts. And especially if you take trigonometry next year, you'll definitely want to know how to convert these. Now we want to be able to go backwards as well. So we want to convert negative 5 pi over 12. And we're going to multiply that by, whoa, why is that moving? Let me try that again. Negative 5 pi over 12. And we want to multiply that by, now this time we're using the other conversion fraction, which is 180 over pi, because we want to go back to degrees. So whatever form you want to be in, it should be on the top of the fraction. So 180 goes with degrees, so that's on the top. So I'm going to multiply this. I get negative 900 pi on the top, and then the bottom I get 12 pi. Conveniently, the pi's go away, which is what we want because we're going back to degrees. And then if you take negative 900, divide that by 12. Let me type that in here. We get negative 75 degrees. Don't know why my writing is moving so much. Okay, and we are going to get negative degree angles, so don't let that scare you or anything. I'm going to continue on here. It's kind of a long lesson. I apologize. So standard position, we are actually going to be drawing angles. It's the position of an angle whose vertex is at the origin and whose initial side is at the positive x-axis. Here's the origin. Here is the initial side. So let's say we want to draw a 45-degree angle. So 45, approximately right there. I'm not using a protractor or anything, that's just my guess. If I were to draw a 45-degree angle, I'm going up from the x-axis. So that's about a 45-degree angle. And we can draw tons of different angles. We usually think of these out of 360. We are going to have some angles that are larger. And we're going counterclockwise in this direction. So we are going up rather than down. When we go down, that's when we're going to have those negative angles. So we could also draw a negative 45 degrees. We would just go the opposite direction. So if I go down like this, that is negative 45 degrees. But notice those are two different positions. That's going to be important. Coterminal angles are angles in standard position that have the same terminal side. Okay? So the terminal side is the ending side. So with this 45 degree, this is the terminal side. And for the negative 45, this is the terminal side. It's wherever your angle ends. So let's say we want to do, okay, we'll do 45 degrees again. Actually, let's do a different one. Let's do 30 degrees. So a little bit smaller. So here's 30 degrees. If I want a coterminal angle, something that's coterminal with this 30 degrees, I'm actually going to complete a whole rotation plus the 30 degrees. So here I'm looping around all the way back up. This little curl that I have here shows that I'm completing a full rotation of the 360 plus 30 additional to get into the same spot. So technically, what I did was I completed a full 360 and then I went 30 more. So I'm going to add those together and I get 390 degrees. So this is 390 degrees. So 30 degrees and 390 degrees are coterminal. It's kind of like if you think of a clock. So here's a clock. Let's say we got, here is our hour hand, here's our minute hand, or excuse me, minute hand. This is, no, ignore this example. But a clock, 1 a.m. and 1 p.m. are in the same position on a clock if you think about it. But what happens is, the reason they're in the same position is because they complete a full turn around the clock, which is 360 degrees. So here, example, 30 degrees and 390 degrees are coterminal. So here's a big chart. It shows a bunch of different angles. So here we have 30 degrees. If we were to go around, we know this would be 390. If we added another 360 to that, we would get 750. So forth. These are all just different examples. So you can have angles that are larger than 360. You can actually have angles that are less than 0, which would be negative degree angles. We'll get into a few more examples with that. But there's an infinite number of coterminal angles. So here we want to draw an angle with the given measure in standard position and then tell which quadrant the terminal side lies in. So negative 120. Remember, if it's negative, we have to go down. So we think of this as 0 degrees right here. So if we're going down 120, this would be negative 90 because we would complete that. So it's going to be approximately right there. There's our negative 120. And this is quadrant 3 that it falls in. So this is 1, 2, 3, 4 for the quadrants. So this is quadrant 3 is our terminal side. Okay, and then we have 400. So 400 is bigger than 360, which means we want to figure out how much bigger it is than 360. So if you were to subtract, we would get 40 degrees. The reason I wanted 40 degrees is because I know where 40 degrees is on my grid here. It's about right there, let's say. So since it's 400, I gotta do a double loop, make sure that I can get all the way around. So here's 400 degrees. and it's coterminal with 40, so it lands in quadrant 1. So I'm just going to put Q1. That's fine if you want to do that as well. 2 pi over 9. Now, once you get good enough with radians, you can probably guess where this is, but we're not there yet, so we're going to convert this. So we're going to multiply by 180 over pi. What happens is our pi's are going to go away. If you think about 180 and 9, we can actually reduce those right away. 9 goes into itself once, and 9 goes into 180 20 times. So 2 times 20 is 40 degrees. So 2 pi over 9 is 40 degrees, which is the exact same one as the last one right here. 40 degrees. And then I always draw that little tiny arrow just to show what direction we're going. And this is in Q1 as well. All right, find one positive and one negative angle that are coterminal with the following angles. So coterminal just means they're going to fall in the same position. So if you haven't noticed this already, whenever you have a coterminal angle, it's either 360 degrees bigger or 360 degrees smaller. Like it has to complete a cycle to be coterminal. So what we can do, the trick is to add or subtract until you get the desired outcome. So if I add 360, I get 460, and 100 degrees is about right there. So if I draw my angle, here's 100 degrees. So 460 is a positive coterminal angle since it's a positive number and it's not exactly 100. Or I can subtract 360, which would be negative 260. So here I get my negative coterminal angle. So for 460, I would just go all the way around like that. And then for negative 260, I would just go backwards like that. That would be my negative 260. All right, 575. This one's a little bit different. It's technically already bigger than 360. So what we can do here is we could just take 575, add 360, and that would give us 935. I don't want to tell you wrong here. 935. Hold on, sorry. 360. Yeah, 935. Okay, now to get a negative angle though, we want to do subtraction. So if we subtract this, we're going to get 215. That is still positive, so we got to subtract another 360. That's not enough to get us into the negative angles. So if I subtract another 360, we end up getting negative 145. So 575 would be, since it's 215, 215 is going to be in this quadrant. So that's about 215 right there. Since it's 575 though, I should go all the way around. So that's 575. Okay, so negative 145 is one of our answers, and then technically 935 and 215 are positive coterminal angles. Either one works. Just has to complete that full 360 cycle. Okay, I'm going to skip the extra practice. I have them in the notes, so go ahead and take a look at those if you want to look at my completed notes, but I'm going to end it there. Let me know if you have any questions.